Okay, now we try again. This will be last, hopefully. We try again to prove whether this argument is valid or invalid. Now the English says, if you wear an enormous cowboy hat, people will stare. If people stare at you, you get embarrassed. Therefore, if you wear an enormous cowboy hat, you get embarrassed. So, what do you say? This is valid or invalid? Okay. So to be sure, we can prove it by using the truth table. So about enormous cowboy hat, we can use this as P. People stare, maybe Q. So if people stare at you, this is Q. You get embarrassed, this will be R. Therefore, if you were an enormous cowboy hat earlier is P. So let me just put here. And you get embarrassed, which is here is R. Okay. Now let's put this into a propositional logic structures. The first statement, if you wear an enormous cowboy hat, people will stare. So we get here if P, then Q. If P, then Q. So this one, first statement, and then full stop, meaning conjunction. The next one, if people stare at you, meaning it's Q, then you get embarrassed. This is implies R. So this is another statement. Now the final statement or the conclusion, therefore, so it will be implies. If you wear an enormous cowboy hat, P, you get embarrassed. So P implies R. Okay, so what do you say this statement? This is true or false? Now let us put again the truth table for this one. But take note, there are 3 atomic propositions in here. So instead of having 4 possible combination, now we get 8 because there are 3. So 2 to the power of 3, we get 8. So I better draw the line here so we can see clearly. Okay. And then I will put it here first. And then here. Oops, sorry. Okay, here. Okay, here. And then here. And then here. Okay. And then, oops, this one. And then here. Okay. So let me put the lines for the row. 1 and then okay. Oops, hold on. Okay. 1 2 3 4 5 6. We need another 2 rows. Okay, let me continue this one first. Okay, in order we can see clearly our lines and row later on. Okay, so now let's put the value. So for P, that will be true, 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 false, 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 false. For Q, that will be true, true, false, false, true, true, false, false. And then here Q, same, true, true, false, false, true, true. false, false. And then R, true, false, true, false, true, false, true, false. Coming back again, P, true, 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 false, 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 and R earlier is true, false, true, false, true, false, true, false. Okay, so now let us try to solve one by one. First, we start with P implies Q, this side, and then see what is the result. This is implies. Remember, implies whenever they are TF, then there will be false. So true, true, false, TF, again TF, FT, true, 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 true. Now let's try Q implies R, the one over here. Again, this is implies, so remember implies whenever TF. So true, TF, true, 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 TF again, true, true. Okay, and the last one here, PR, P implies R, so we have true, TF, true, TF, true, 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 true. Okay, okay, now we look at the first one here, conjunctions between these two. Remember conjunctions whenever they are true. So true, true, we get true. True, false, we get false. False, true. False, false, true. False, true, true. True, true, false. False, true, true. True, true, true. True here. Now result of this pair with result of here. So remember again implies, I will use green. So true, true, false, 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 true, false, false, true, true, false, true, 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 true. Voila. Now we can see that the result all are true. So meaning this is valid. So our statement here, our argument here is a valid argument. Okay? So we already see a few examples already about valid argument. We already see one here, and then two here, and then three, and then four, and then five here. So we can make a use truth table in order we can prove whether the arguments is valid or not valid. So whenever all the final results to the conclusion is all true, this is valid. If it is somehow like this false, then it becomes invalid, like that. So only when all are true it is valid, and if there is any false in between, either only one, then it becomes invalid. Now I would like to talk about these last examples. You see here we have three atomic preposition. So three meaning we are about to build or construct truth table with 8 possibility combinations. So we have 8 rows in here, as you see, like our example here. Imagine if you have 4 atomic proposition. So how many rows are you going to construct here for the truth table? That will be 16. Now you tell me, in the real life case scenario, how many atomic proposition do you think you are going to have? Or when you do programming or build an applications or computer system, like for example ATM system, how many atomic proposition do you think you will have? That will be very many in there. So it can be 10, it can be 20, it can be 100. Imagine if you have 10 only, so how many rows are you going to have? With 10 atomic proposition, you are going to have 2 to the power of 10 rows already for the truth table. You can calculate how many 2 to the power of 10. 2 to the power of 3 you have already 8. 2 to the power of 4 you have already 16. 2 to the power of 5 you have 32. 2 to the power of 6 you have 64. 2 to the power of 7 you have 128. 2 to the power of 8 you have 256. 2 to the power of 9 you have 512. So 2 to the power of 10 you have 1024. Imagine if in the exams, or not even in the exam, if I give you a quiz or tutorial or assignment with 2 to the power of 10, with 10 atomic propositions. So you need to construct 1024 rows for the truth table. So you can imagine how much work that you need to do. So what I'm trying to say, to prove whether an argument is valid or invalid with the help of truth table have the limitation, because the more atomic proposition you have will be the more rows are you going to have in the truth table. So what can we use in order we can solve the limitations of this truth table? So the questions for the answer is going to be our next discussions, which we call proof theory or proof sequence. Remember, I mentioned this sequence in the very beginning of the class today. I will scroll so you can remember again. It's in here now. You see over here. See how conclusions are drawn from a set of statement reasoning. So we can make use of this in order we can prove whether an argument is valid or not. Okay, so let's proceed to that one. How is the proof theory or proof sequence works? Okay.